Welcome back, students. So here I have come with another new episode on the chapter current electricity. So I already uploaded two episodes, okay, on this chapter. So if you meet those episodes, you can subscribe my channel, Physics Scholar, and you can watch the episodes and also follow the description box. Okay, I will also share you the links and also write in comment that you are understanding it properly or not, and if you want to see the more videos, okay, then also write in comments so that I can get inspiration from that. Okay, so now, as in the last episode I discussed about the series combination of resistances. Okay, what is the series and what are the advantage of the series circuit, okay, disadvantage of series circuit, and what is the equivalent resistance of the series circuit. Equivalent resistance means the summation of all the resistances which are in series. Okay, so today we will talk about the parallel circuit. Parallel combination of resistances of parallel circuit. Okay, so suppose we are taking three resistances. Okay, it is R1, it is R2, and it is R3. Suppose let us consider three resistances. Okay, so when it will be connected in parallel, how it will be connected when they are in parallel? In case of the series, we know that one resistance, the end of one resistance will be the beginning of the another resistance, and the end of that will be the beginning of another. That means one after one we are connected. Okay, we are connecting all the resistances just like a chain. Okay, but here the one end of all the resistances will be connected to a common point. Will be connected to a common point, and other end of all the resistances will be connected to another common point. Suppose this common point is A and this common point is B. Okay, so what the one end of all the resistances, this is one end. Okay, resistance R1, R2 and R3 are there. Three resistances are there. Resistances are there. So the one end is connected to one point and the other end is connected to another point. Okay, so this combination, okay, this combination of resistances is known as parallel combination. That means what? One end of all resistances are connected in one point, and other ends are connected to another point. Okay, so you see the diagram, one end of all the three resistances are connected at one point and other ends are connected to other point. So let the two common points are A and B. Okay, now if we connect it with a battery, okay, suppose this is the battery, so the potential difference of the battery is V. Okay, this is the positive side, this is the negative side, and the current is I. Okay, current is I. So what we have seen in case of the series, the same current is flowing through each of the resistances or each of the devices. But here, when it will come to point A, then it will be divided. Suppose in three parts, one will go to this branch, another will go to this branch, and another will go to this branch. So it will come same current I1 through this, I2 through this, I3 through this, and here it will again meet, and the I1, I2, I3 will again meet over here, and it will prepare and then it will come back to the battery. Okay, so this is how the current can flow through a parallel circuit. Okay, that means the amount of current through each resistances will not be, or each devices will not be same. Okay, it will be splitted, and it will be splitted into different parts and will pass to each of the branches. And how much it will the current will flow through each branches. That will depend on the amount of the resistance. Okay. Suppose this is what VA and voltage at here is VB. Okay. So you see the thing here, the potential difference across each resistances are same. That is what VA minus VB. As the current is flowing from A to B, that's why the potential of A will be higher than the potential of voltage of V. So the potential differences will be A VA minus VB. Okay. So the potential will be VA minus VB, and that will be same for all the resistances. Okay. The potential difference across each resistances will be same if they are connected in parallel. But the flow of current through each resistances will be different. Here it is I1, here it is I2, here it is I3. So what are the characteristics of parallel circuit? The voltage or potential difference across each resistance or device will be same. Number 2, the current through each resistances or devices connected in parallel are different. Okay, are different. Now suppose this instrument get damaged. So what will happen? The current will not flow through this path. But the current can flow to this path and this path. Okay, so this path will be closed. Okay, so current will not flow through this path due to the damage of this instrument or device or the resistor, but current can flow through this and through this path. Clear? So that means what? In case of the series, what I told, in case of the series circuit, okay, if any instrument get damaged, then all other instrument will not work. But in case of the parallel, if any instrument get damaged, then all other will work fine. So how the electrical instruments are connected in our household circuit? Parallel. Okay, so that's why if one bulb is fused or one fan is not working or one fridge is not working or one AC is not working, whatever, if one instrument is not working, then also the other instruments which are connected in our house will work fine because they are connected in parallel. So this is the advantage of parallel circuit. What is the advantage of parallel circuit? If any instrument get damaged in case of the parallel circuit, then all other instrument will work fine. Okay, that instrument will not work because that is damaged. Okay, so we have to replace that or we have to repair that. Okay, but the other instrument, no effect will be there. Okay, for the damaged instrument, they will work fine. Clear? So that is the number one advantage of parallel circuit over series circuit. Another advantage. Another advantage is what? The potential difference. Current may be different from each branch, but the potential difference across each resistances or branches will be same. That's why all the instruments which are connected in parallel, they will get the same potential difference. Okay, suppose the potential difference of the instruments which are connected in is 240 volts. Suppose, clear? So what will happen? All the instruments which are connected in parallel will get the same potential difference 240 volts. So they will work with full efficiency. Okay, as the voltage potential difference across the two terminals for all the devices which are connected in parallel will be same. So they can work with full efficiency. All the bulb will glow with full brightness. Those who are connected in parallel. Okay, but if the bulb is connected in series, then what will happen? As we move from the first bulb to the last bulb, towards last bulb, then what will happen? In every case, the voltage drop will be there, and the last bulb will not glow with the full efficiency. The glowness of the bulb will be decreased. Okay, is compared to the first bulb. Okay, in case of the series, but in case of parallel, suppose 100 bulbs are there connected, so all will glow with the full brightness if they get the sufficient amount of voltage or desired amount of voltage, and the voltage will be same for all. Clear? So these are the advantages of parallel circuit. Clear to all of you? Now, how we can determine the equivalent resistance of parallel circuit? In case of the series, I told in the last episode that equivalent resistance R is equal to R1 plus R2 plus R3 plus, if the number of resistance is n, then it will be only the summation of all the resistances in case of the series. Okay. Now let us see in case of the parallel what will be there. In case of the parallel circuit, okay. So I am drawing the diagram first. Okay, let us consider about the three resistances. Okay, the resistances may be 4, maybe n. Okay, but we are considering about the three resistance. Okay, so the same diagram I am now drawing again. Okay, so it will be R1, it will be R2, it will be R3. Now it is connected with the battery. It is connected with the battery. The voltage of the battery is V. Okay, the main current from the battery is I. Okay, it is point A, it is point B. Okay, and it is what? It is I1, it is what? I2, and it is what? I3. Okay, it is also the same I1, I2, I3, and it is also again I. Okay, so I will return back to the battery. Now, it is here is VA and it is VB. Okay, here. Now what happened? Okay, now say, okay, so here VA minus VB. VA minus VB is equal to what? I1 into R1. Okay. So I1 is equal to what? I1 will be VA minus VB by R1. VA minus VB is nothing but V. So V by R1. Similarly, I2 is equal to what? V by R2, and I3 is equal to what? V by R3. Okay. Now, okay. Now, if we add the 3, so I1 plus I2 plus I3 is equal to V common 1 by R1 plus 1 by R2 plus 1 by R3. What is I1 plus I2 plus I3? That is nothing but I. Okay, I is split into 3 parts. So if we add this 3 part, then it will be I. So I is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this is number 1 equation. So let the equivalent resistance is R. Let the equivalent resistance is R. Okay. Let equivalent resistance. Okay, resistance is R. Okay, so what will be the equivalent circuit? Just like this. Okay, so we are replacing all the resistances by a single resistance R. Okay, that is the equivalent resistance. So what is left? Only the battery is left. Okay, it is A, it is B. Okay, it is V. Okay. So it is I, so it will flow the same current, it is I. That is known as the equivalent circuit. It is also I. Okay. So now, what is the equivalent resistance R? So what we can write? Okay. V is equal to I into R. So that means I is equal to what? V by R. It is number 2 equation. So it is also I is equal to this. It is also I is equal to this. Okay. So by comparing, what you can write? By comparing, what you can write? V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So VB will cancel. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If the number of resistances is n, if there are n number of resistances, okay, n number of resistances. So what will be the equivalent resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus plus 1 by Rn. Okay, so that will be the equivalent resistance. Those are connected in parallel. Okay, so this is the mathematical expression how you can find out the equivalent resistances for the parallel circuit. Okay, so the parallel circuit means the resistances are connected in parallel. So the reciprocal of the equivalent resistance will be equal to the sum of reciprocal of all the individual resistances. Okay, so that is the equivalent resistance of a parallel, and from this equation you can easily find out the value of R if we know the value of R1, R2, R3 and all. Okay, now for the two resistances, suppose we are assuming two resistance. Okay, so R1 only and R2. So what will be the 1 by R is equal to 1 by R1 plus 1 by R2. That means what? 1 by R. So what will be the LCM? R1, R2. then it will be what? R2 plus R1. Okay, that means R is equal to what? R1 R2 by R1 plus R2. Okay, so for the if two resistances are connected in parallel, if two resistances are connected in parallel, then what will be the equivalent resistance? The equivalent resistance will be R is equal to product of the resistances divided by the sum of the resistances. Okay, the product of the resistances divided by the product of the, it is applicable only for the two resistance which are connected in parallel. So it will be R is equal to R1 R2 divided by R1 plus R2. Clear? So this is the shortcut method we can use while we will do the numeric sum. Okay, and in general, what is the general formula? General formula is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot 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 plus 1 by Rn. Okay, so this is the equation of to find the equivalent resistance which are connected in parallel. Okay, so I think this part you understand. Okay, so the advantages of series circuit, parallel circuit, okay, all you have understand now. So if you have any doubt, write it in the comment box, okay, so that I can explain that. And if you want the notes also, write it in comment box and share your mail ID. So I will send it back, okay, to you. I will respond you 100%. So you have to say your problems, okay, in the comments. And you are understanding it or not properly, that also you have to write in comments. Okay, that is my expectation from you. Okay, so now, so that is the series and parallel circuit is completed now. Okay, so next, what is known as lost volt? Okay, lost volt in case of the battery. Okay, that is also a very important concept. What is known as lost volt? Clear? So what we know that suppose this is a battery. Okay, it is a battery. Okay, it is the positive electrode, it is the negative electrode. So if we connect it with okay, with a very minimum resistance, then what will happen? The current will flow from positive to negative terminal. Okay, suppose the current is I, so the current will flow from positive to negative terminal. Okay, and the battery has a one EMF. It is known as electromotive force. Okay, one EMF. Okay, that EMF is E. Okay, so inside the battery, the current will flow from negative to positive terminals. Okay, the current will flow from negative to positive terminals. Okay, and as the resistance in the outer circuit is there, so when the current is flowing inside the battery, then also it will experience some resistances. Okay, so that is known as the internal resistance of the battery. So small r is equal to what? Internal. Okay, internal resistance of battery. Okay, it is known as the internal resistance of battery. Okay, so for the outer circuit there is the resistance for the circuit. Now when the current is flowing inside the battery, okay, the battery will also, the chemicals which are used inside the battery, acid or whatever, okay, so that will also offer a resistance. Okay, that is known as internal resistance, and E is equal to EMF. Okay, so that is known as the internal resistance of the battery. Okay, so what is the internal resistance of the battery? Is molar. Okay, so now when it is not connected, when it is connected, then the outside potential difference is V. The outside for this outer circuit, the outside potential difference is V. Okay, so what is E? E will be what? E will be what? V plus what? I into small r. Okay, I into small r. Okay, so what we can write then? V is equal to, okay, E minus I into small r. Okay, so that means what? The outside voltage, the potential difference. This is the potential difference. The potential difference is what? Lesser when it is connected to the outer circuit. The two terminal of the battery is connected to the outer circuit. Then potential difference is lesser than the EMF of the battery. Okay, why? For this. Okay, for this. Okay, so it is what? It is known as, so this is the this is the lost volt. This is known as the lost volt of battery. This is known as the lost pole of battery. Okay. So due to this, there is the outside circuit, the potential difference is smaller than the EMF of the battery due to the lost pole. Okay. So when the current tries to flow inside the battery, then it will also experience some resistances. So that is R. So the lost volt will be small v is equal to lost volt, small v is equal to I into small r. Okay. So that will be subtracted from the EMF of the battery, so which will be equal to the potential difference of the battery. Okay, for the outer circuit. Clear? Okay. So that is equal to the potential difference of the battery. Now suppose I am now omitting this outer surface, outer circuit. Okay. That means battery is not connected to any circuit. Then what will happen? Then what? This I will be 0. That means I will not flow. So I will be what? When the circuit is open, that means it is not any current is not flowing. So when circuit is open, okay, circuit is open. That means what? That the two terminals are kept open. Okay, it is not connected with any wire. Okay, then what? I will be 0. Okay, so if I is 0, then what? E is equal to V. Then E is equal to V. Okay, so in that case, the EMF will be equal to the potential difference of the battery. Okay, so what is the definition of EMF? What we can write? The definition of EMF. Okay, so what is the definition of EMF? When the battery is not connected with the outer circuit, then the potential difference of the two terminals of the battery, is known as the EMF of that battery. Clear? So when no current is flowing, no lost volt is there. Okay, so at that time the potential difference of the battery is known as the EMF of the battery. So when the two terminal of a battery is not connected, then the potential difference between that two terminal is known as EMF of that battery. Okay, EMF of that battery. Clear to all of you? Now in that case E is equal to V. Clear? In that case E is equal to V. Okay. Now the next thing is what? What we know? E is equal to V. Okay. Now E is equal to again V is equal to again E minus I into small r. Okay. So see, if the value of R increases, then what will happen? V will decrease. Okay. If value of small r increases, then also V will decrease. Okay. So when it will be equal to E, then what? V will be 0. Then the potential difference when IR will be equal to E, then what will happen? V is equal to E minus E. That means V will be 0. So if the huge number of current is drawing, then what will happen? One time will come when this value will be equal to this value. That means what? The potential difference will be 0. Clear? So that means what? That means there is a limit of a battery to flow of current. The battery cannot supply huge amount of current. There is the upper limit. Okay. Otherwise, what will happen? The EMF will be equal to I into R, and the outer potential difference will be 0. That means no current will flow. So that is I is equal to what? E by small r. Okay. So that is the upper limit. So what will be the value of EMF? If we divide it with the value of internal resistance of the battery, then we will get the maximum amount of current that is allowed, okay, by that battery, okay, to flow. If it exceeds more than that, then what? No current will be drawn. Okay, even if it is connected with the outer circuit. Why? Because it will be equal to E and the potential difference will be 0. If the potential difference is 0, then no current will be drawn. Clear? So this is the thing. So if I and smaller cannot be huge, okay, cannot be equal to E, okay, otherwise the potential difference will be 0, and if the potential difference will be 0, then no current will be drawn in external circuit, okay. So I think it is clear for you now. Now one very common question comes in the examination also, okay. One common question comes in the examination, that is known as the difference between potential difference and EMF of a battery, okay. So many students don't have a clear concept about the potential difference and EMF. What is EMF and what is potential difference? I asked many students. They cannot explain properly because they don't have the basic idea what is known as the potential difference and what is known as the EMF of a battery, electromotive force of a battery. Okay, so I am explaining this. Okay, if you can listen it properly, then you will able to understand the basic concept. Already I explained. Okay, while I am explaining the lost volt. Okay, I into smaller. Okay, so suppose this is the battery. I am explaining this once again. Suppose this is the battery. So due to the I am writing it like this, so you will be able to understand. Okay, it is not positive terminal, it is negative terminal. So when it is not connected, then the EMF is E. Then the potential difference across two terminals is equal to the EMF of the battery. Clear? And here it is smaller. The internal resistance of the battery is smaller. Okay, and the current flow, if it is connected, is I. Okay. So what will happen? Okay. So when the battery is connected with the external circuit, okay, then what will happen? Current I will flow, then what? V is equal to what? EMF minus lost volt. So due to E only, the potential difference is created. So potential difference is the effect of EMF and okay, EMF is the cause of potential difference. Okay, EMF is the cause of potential difference. Okay, and the potential difference is the effect of EMF. Due to the EMF, the potential difference will be created. If no external circuit is connected to the battery, then the EMF and potential difference will be same. So when it is connected, then due to the lost volt, the voltage will be. That means what? Lost volt will be there. If lost volt is not there, R is equal to 0. Then also V is equal to E. So the value of the potential difference cannot exceed, okay, the value of EMF. So the value of potential difference should be less equal to EMF. Okay, EMF of the battery. So value of potential difference cannot go exceed the value of EMF of that battery. It will be either equal when it is not connected or less than, okay, the EMF here. And so this is basically the two major differences between the potential difference and EMF of a battery. So what is shunt? So before we start the shunt, we have to understand what is galvanometer. Okay, what is galvanometer? Actually, galvanometer is an instrument which is used to identify if any current is flowing through a circuit or not. Okay, just like the tester, we are using a tester to identify by blowing of the light that the current is there. Okay, so in galvanometer there is a indicator which will reflect. Okay, and we can understand that the current is flowing through this circuit. Okay, so suppose this is a galvanometer. Okay, but what is the problem? The resistance of the galvanometer is G. What is the problem of the galvanometer? If it is connected directly to the battery or to the circuit, then what? It has also range. That means up to this amount of current it can resist. If the amount of current is more than that, then what will happen? The galvanometer cannot resist and it will be damaged. Clear? So what will happen? What we have to do? We have to use one resistance having low value. Okay, that resistance is known as shunt. Okay, So suppose the resistance is S, okay, and this will be connected in parallel, okay. So suppose this is the circuit, okay, and it is VA for point A, and it is V, and it is VB, okay. So it is plus, it is minus, and it is V, okay. So the main current is I, main current is I. So it is what? It is IG, okay, and it is what? IS, okay. So that is the current, and here it is again I, okay, and it will come inside the battery. Now the thing is that galvanometer resistance is galvanometer, manometer resistance is G, and shunt resistance is what? S. So these are connected in parallel. So equivalent resistance what? R is equal to what I told? Product divided by their summation. Product divided by their summation. Okay, of the resistances. Okay. So what is now you can write potential difference VA minus VB is equal to I into R. So I into G into S by G plus S. Okay. So now what is the galvanometer flow? I is equal to VA minus VB by what? G. Okay. So it is IG. Okay. So IG is equal to, or capital G, I am using here capital G, so I am writing here capital G. Okay, no problem. So IG is equal to VA minus V means what? I into G into S divided by G plus S into what? G. So G will be cancelled. So IG is equal to what? I into S by S plus G. Okay. So see how we can remember it. We will remember what is the tricks to remember. IG means galvanometer flow. When we are calculating the galvanometer current, okay, then we have to take, okay, the resistance of the shunt. When we are taking the galvanometer flow, then we have to first take the resistance of the shunt. So we will do like this. So what is there left? Shunt. So resistance of the shunt divided by what? The sum of the resistance of G and S into the main current. Okay. Similarly, what is 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 equal to I. What is IS? I into what? I into VA minus VB by S. Okay. So I into what is the VA minus VB? G into S divided by G plus S. Okay. Into S. So IS means what? I into G divided by G plus S. So when the current will flow through shunt, okay, then what? We will take the resistance of galvanometer divided by the sum of galvanometer and shunt. Okay, resistance. Okay, so this is how we can determine the flow to the galvanometer and to the shunt. Okay, so what is the power of shunt? Now, what is the power of shunt? We will now discuss the power of shunt. Here, what is the power of shunt? Now, let us discuss about the power of shunt. Clear? So now what is the galvanometer power? Power of shunt. Okay. Power of shunt means what? If the power of shunt N can be divided if only 1 by nth of main current can flow through galvanometer, then the power of shunt is N. Okay, the power of shunt is N. That means, okay, whatever the value of N, only the reciprocal of that amount of current can flow through galvanometer, and the rest amount of current to flow through shunt. Okay, so that is known as the power of shunt. Okay, so now that means what? Ig means galvanometer flow is equal to the main current is I into what? 1 by N. So what is the so Ig by I is equal to what? 1 by N. So what is the value of Ig? Just now I told Ig is equal to what? I into galvanometer resistance divided by what? Summation of galvanometer and shunt resistance. Okay. So that is what. So what we will write? I into S by S plus G whole divided by I is equal to 1 by N. Okay. So this we can say. So divided by S plus G is equal to 1 by N. So what you can write? S by G is equal to 1 by N minus 1. Okay. Therefore, S is equal to G divided by N minus 1. So S means what? The resistance of shunt. S means shunt resistance. Shunt resistance. Okay. So how we can determine that how much resistance we have to take as a shunt? If we know the resistance of galvanometer and the power of shunt, then by this formula we can easily determine the resistance of the shunt. Shunt resistance is equal to G by N minus 1. Okay. So if we can know the galvanometer resistance and the power of the shunt, then we can easily find out the shunt resistance. Okay. What should be the value of resistance of the shunt? Okay. So students, I hope this part is now very clear to you. Okay. So in my next episode, I will discuss about the ammeter and galvanometer. Okay, and voltmeter. Okay, and also I will discuss the some numeric problems. Okay, some simple to higher. Okay, and some more concept. Okay, about the temperature coefficient of resistance. Okay, and slowly we will move to the Kirchhoff's law and some tricks to how to solve the complicated electrical circuit. Okay, so keep watching my channel. Thank you.